the whitehouse.gov site, but it didn't use the DNS entry, it used that IP address. So everybody just null rounded it. Well, we can all, I hope that's not reissued to anybody, but we can all just send it somewhere. And then the timeout stuff that the Ajax calls or whatever happens, it's still going to time out, but it'll all time out the same. All time out the same. We're removing that pattern. So we're kind of neutering the payload. We're not running the payload. So we don't have to catch the whole payload. We're just making it go somewhere else. Again, this does lean heavily on normalizing that IP address. This is only the normal IPv4 format, right? What about the octal format or decimal format of the IP address? So we want to catch those too. But it's a start. You know, this is, I can only fit so much on one slide. So that helps some of those payloads. We can catch it outside, even if our somehow somebody figures out how to make our browser not go through the proxy. We can have the proxifying process capture and send it through there anyway. All right, that does, if we're black holing the IP address, that takes care of that. Now the real problem though turns out that, well, stuff back to yourself is still problematic. If it goes back to localhost, a lot of things don't get captured. Like Internet Explorer doesn't necessarily, even though you can tell it what host to go to, and it does put localhost in there when you're accepting proxies, when you just set it manually, still a lot of things still work even if you remove that. So we still want to be able to hijack the browser itself, not just surround it in a proxifying thing. All right? But this actually takes care of a lot of our problems with at least the payload stuff and some of the identification of your internal network, not just your own local machine. All right? But if there's port scanning or the beef, the browser exploitation framework stuff, is mostly defeated by just doing this internally. I mean, yeah, your browser's still zombified. They can make you do stuff like go hit ads, but they're not going to find out more against your internal network. Now, as far as payloads like cross-site scripting and classic stuff, that's tough. Again, it's been tough. It's been tough for everybody. Everybody gets bit by cross-site scripting eventually. It's one of those kind of things. So it's tough to do it reliably, but maybe that's a good voting system for us, right? We have the no script way to do granular, allow this object or this function, but people vote on what's good, or we rate on how dangerous that script might be, and then go through and add that up through the page, and then you've got a rating system like Spam Assassin that says this page looks a little more dangerous because of these types of scripts that are going. And you know, you weight the JavaScript body that was between two script tags, it's all encoded and not clear text. Well, that might, you know, be worth a point. If it talks to the navigator.plugins object, well, maybe that's 3 points because, you know, just use the plugin. Don't ask me for my plugins, just use it, you know. That's not something I want you to do. But maybe we can add that up and aggregate it to know if that is a dangerous thing to block or not. Of course, that's going to require a lot of work and a lot of ongoing work, but I'd like to add that in with this project that we've started. Part of the problem is too, like Peter was saying with Panopticlick, there's not a lot of good data out there about things like this, but we have to start collecting it. We got to start somewhere and then decide how realistic that is before we know where to go with it. So I think really the way to solve some of the problems that are introduced with extensions and browsers that are less than desirable, vendors are taking too long to deal with things. There's a lot of finger pointing at certain organizations. And, well, some of the finger pointing is deserved, don't get me wrong. Certain people are more fault than others, that's for sure. But until then, it's nice to be able to defend yourself. So between a browser extension or browser helper object and a proxy, we can really increase a little bit of safety. We can't take care of everything, but we can really take back control of our desktop a little better. So the suite we're doing, we're hosting it at SourceForge. It has everything we can is actually done in JavaScript to make it injectable. Wouldn't that be great if you injected in your proxy to protect your innocent sheep workstation guys, the stuff that would defeat things. So they browse somewhere and your proxy injects it instead of then figuring out how to disable their browser or using an unapproved browser on the network or something like that. So we try to do everything we can in JavaScript to supplement it. There are browser helper objects that give you the visibility into the browser itself. We've had a few of those now that we've built, and we've leaned real heavy on those third-party tools. That's why we just call it a suite. So we have tools that do good stuff for us, like NoScript is pretty good. And if you saw the talk last night on Blitzableiter, sorry, German in the morning, not so good. Awesome stuff, but we need them all. So we're trying and get things all integrated. All right? If we combine that with a repository of signatures, then we don't have to be completely anonymous. We can just look like everybody else is that. All right? Definitely looking for contributors, though. Contact me if you feel like you've got some resources you can put towards it. Both contributing signatures, and we have a lot of work to do on code. So what we've leaned heavily on so far to kind of test things out was Fiddler. If you haven't seen it before, you probably should. Maybe you've heard of it and said, yeah, it's just another proxy. It's actually pretty slick because it has several cool components. Of course, it's portable enough in .NET 2.0 as far as being able to run it on Mono. It also works with Proxify, big plus. There's not a problem with that. Even though it only naturally looks at HTTP and HTTPS, we can still make everything the browser does, everything Fiddler does, go through a proxy, which is pretty awesome. And it has Fiddler core, not just a GUI that lets you control stuff. We can actually consume its library by a .NET application and leverage the hijacking of our own browser, both as a proxy and as a hook into the browser. Okay? So it is written for Windows, but it can be used for other things. And it can be, because it is a full-fledged proxy, you can send it traffic from other places. One of the coolest extensions they have for Fiddler is a DHCP spoofing proxy detection hijack. It's an extension for Fiddler that'll go hijack the DHCP and tell people where the proxy is for the automatic detection. Pretty slick. But you can get it. You can get the source code. Lots of cool things happening. 2.3.0 was released on, what was it, Wednesday, maybe Tuesday. Pretty cool stuff with Fiddler. What are we looking at doing? Well, switching from the classic antivirus signature detection stuff more towards fixing what the browser should be doing anyway. Defanging the stuff that's non-compliant and rebuilding it. The Blitzableiter style from last night, hey, we don't have to match the bad flash because they're so bad at writing it, we just have to break it apart, look at it, find out why this is non-conforming, and then that's probably enough reason to know it's bad. Not just for detection, but what if we rebuild it? Is the emphasis on defanging it, right? Go through and fix the code so that it's realigned. If it was a payload that was written to get around some filtering or written poorly, it breaks it often. Clean up the bad guy's code, and sometimes it doesn't work. Even if it doesn't work, well, at least now it's easier to do signature detection on once it's cleaned up. So that's the idea there. All right, some other things that might be interesting that we're starting to experiment with a little bit, but we haven't got that far in the project, is using basically copying into a temporary file how the browser rendered the page. So using the document object model to print what it says to a file, and then faking the user agent string to a different user agent, or maybe grabbing another browser instant specifically, and then basically hitting the page 3 or 4 times with different configurations, see how the page is different, and then diffing them to see how different they are. Now, just the fact they're different isn't good enough, but if there's just some subtle differences, maybe that's interesting to us. So that's something we're starting to look at. I don't know if we can get anything out of it, but it would be kind of neat to see if, wow, this is only exploiting Internet Explorer 8, and the Firefox and the Opera version of the page both seem to render okay and are very similar. They're not trying to exploit you. Or if you come in as Googlebot, what do you see? Those kind of things. Could be, especially if we do the weighting, the spam assassin style of how dangerous it is, we could pick the least dangerous version to display to the browser. significant overhead, but I'm kind of liking the idea of being able to look at things in 4 different ways at the same time. All right? Using an alternative browser to render that. All right, so demos, I'm not dumb enough to try and show you something, see how it doesn't work, it breaks it. I learned last time. Showing you something that's supposed to be not working is not very helpful in a demo, because see, it didn't work. But I've got some screenshots. So, for example, here's just a simple JavaScript enumeration. It uses the navigator.agent, pulls it in. Now, if you fake your user agent string, this still says the real user agent string, or the real browser agent, because it asks via JavaScript what it is. So you spoof your user agent string, not good enough. The HTML source code shows you there. It's just the navigator.agent object. Although I just realized I mistyped it in the left-hand side of the equal sign. Navigator.userAgent is correct on the right-hand side. Once we've injected our custom JavaScript kludge, which it is, I'll admit, not perfect, but hey, it's good enough. It's better than what we have. It sees that, fakes it. Now the cool thing about Fiddler is, even though HTTP is sessionless itself, right, you have request response, and that's it. The application depends on things like cookies or session IDs to tie them together. Fiddler does its own session mapping to request and response. It says, this is the response for the request I just sent. And that gives it visibility to what request it sent. So it grabs what user agent you spoofed and responds and just directly inserts the string there. Again, not perfect, and it's easy to break this. If I put in window.navigator.agent, then in the resulting source code here at the bottom of the slide, it will actually window dot and then the double quote in the string, which JavaScript's not going to like. It wants it to be concatenated with a plus sign, right? But guess what? Hey, if we broke the script, great. I'm all for that. You know, I'm perfectly fine with breaking the script that probably is just enumerating my navigator agent. I don't care. Client side, my agent knows what it is, right? I mean, what use is that? You're telling me to ask myself who I am. So what, I mean, an application that does that is only, you know, either written silly or up to no good. So if it breaks it, great. It happens to work out great for that. Now the actual Fiddler code that changes that code looks like this, all right, where first we just, to try and minimize the signature detection against every kind of content, we only look at the HTML. We go through and normalize it to UTF-8 as best we can, which actually works fairly well. And then if there's a navigator.something anywhere in the page, which would even be JavaScript, it's going to go through and replace it. There's a couple of ways to do it. One is to actually change the length. And that's actually for the plugins that if you ask navigator.plugins what plugins you have, and you can actually set the length equal to 0, and then it won't show up as navigator.plugins in Firefox right now. I don't know how long that's been. I haven't regress tested that the whole way. But it's kind of cool. If I inject navigator.plugins.length equals 0 into something that's enumerated in my plugins, it shows up with no plugins. Of course, they can still try to use the plugin and know it's there. And that's the easy way. But this is one way. You know, your system can have these fingerprints in any different combination. You have to be able to feed all of them. So that's what the first one does. But this user agent string at the bottom is the one that replaces it on the request. Sorry, it replaces it on the response, but from the request, which is why having both a browser helper object and a proxy together is the way to go, because we can now track the session real. All right. Here's the navigator.plugins enumerating. This is the result of what it looks like when it works. This is just a proof of concept here. Was this from... I think I leaned on Browser Spy for this one. And of course, once it's working, see, it doesn't work. No plugins. And all we really did was we injected it equals 0, prepended it to whatever was there. Turns out that's good enough. It breaks it. That's fine with me. If it didn't break it, depending on if they just didn't set it to